Simplifying complex expressions with division. So what I want to show you is how we can simplify these complex fractions in the forms of rational expressions with division. And it's very similar to what we did with the regular fractions where we didn't have any variables. So what we're going to do is we're going to rewrite this, since we have a fraction on the top and a fraction on the bottom. We're going to rewrite this as a division problem or division statement. So 6 over x minus 4 divided by 3 over x squared minus 16. And now when we look at this problem, really rather than it looking like a big, ugly, complex fraction, we can see it as just a division problem, the type of which we know how to solve. So I'm going to flip and multiply the second fraction. And now all of a sudden we have just a multiplication problem. I'll do a little factoring. 6 over x minus 4 times this fraction here has a difference of squares. That would be x minus 4 times x plus 4 all over 3. And then simplify. Cancel, cancel. 1, 2. And I have on top 2 x plus 4, and on the bottom nothing left, so it's not even a fraction, it's just 2 times x plus 4. So my strategy was to write this complex fraction as a division problem. So in this next example, we're asked to simplify this complex fraction that has two fractions added together in the numerator and then two fractions subtracted in the denominator. So like what we were doing with the numerical examples, we have to first put these into fractions before we can go into our division problem. So 1 over x plus 1 over y over x over y minus y over x. I'm just giving myself some room to work with. I have to combine these fractions, top and bottom, to turn them into a single fraction. So I have to get common denominators. I'll have to multiply this one by y over y, multiply this one by x over x. That's what I'm going to have to do in the numerator. In the denominator, I'll have to do something similar. I'll have to multiply this by x, and x on top, x on bottom, and y on top, y on bottom. And now I'll go ahead and see what I have. So I have y over xy plus x over xy over x squared over xy minus y squared over xy. So here we go. I can continue along here, and now I'm going to combine these fractions now that they have common denominators. So that would be y plus x in the numerator over xy over x squared minus y squared over xy. Just want to write that a little neater. And now I'm in the point where I can flip and multiply much easier, because now I have a fraction, one single fraction on the top, which is this guy, and one single fraction on the bottom, which is that guy. So that would be y plus x over xy divided by x squared minus y squared over xy. And now we're ready for that flip and multiply step. Times xy over x squared minus y squared. There we go. And we see some really nice canceling here. And I also note that this is a difference of squares here. So before I call it a day, I'm going to write that as x plus y times, so if canceling happens, it leaves us with 1. I'm going to factor this because that's a difference of squares. So that would be x minus y times x plus y. And a little more canceling is still to happen. So we can see that we have x plus y on the top, x plus y on the bottom cancels leaving me with just 1 on top and x minus y in the denominator. So similar strategy to what we were doing with the numerical examples. It's just that now we have to use our skills for adding and subtracting rational expressions, and we have to do that in the numerator and denominator so that we can flip and multiply to simplify that complex fraction. And finally, one last example. I'm going to start going through this one a little bit quicker. So I need to combine these fractions. So what does n need? N needs to be have a denominator of n plus 5. So I have n minus 4n over n plus 5. I have to multiply that first term by n plus 5 over n plus 5. So that we have a common denominator in that part. In the bottom, I have 1 over n plus 5 plus 1 over n minus 5. And I'm going to have to multiply by n minus 5 there and n plus 5 here. So again, I'm using these skills of adding and subtracting rational expressions as a sort of intermediate step. So it's really important that I'm comfortable with these skills. So there's my fraction in the numerator. So that was just all of this part I've simplified. And now this is all divided by the fraction on the bottom, which is n minus 5 plus n plus 5 over n plus 5 times n minus 5. So this is the fraction here on the bottom. And now I can flip and multiply. So I have some simplification I can do in the numerator, n squared plus n over n plus 5 divided by, and I have some simplification here, those 5's cancel. So I have 2n over n plus 5 times n minus 5. And flip and multiply. I'll do the factoring in the next step, just so I don't complicate too many steps at once. It's easy to make mistakes if you try to do too many things in one single step. So I'll just try to keep it simple for now. And let's see what'll cancel. I'll have to do some factoring. This first fraction factors like that. And the second one, I'm trying to get out of the habit of writing my multiplications as x's, especially when you have all these variables. You may as well just use a little dot. And now let's see what cancels. N plus 5, n plus 5, n. And so it looks like we are left with n plus 1 times n minus 5 in the numerator, all over 2 in the denominator. That's all that I have left down there. And so there we go. This is just one last example of using division to simplify these complex rational expressions.